Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay. My name is Muhammad Hadi Haris bin Razahar. We are from Group 11. We will discuss about 7 QC tools. Okay. First is histogram. Histogram is a bar graph that represents frequency distribution of value in each bar. Histogram from a Greek word histo and gram. Histo is a Greek word that means web or mass, and gram is a word that indicates drawing, recording, or writing. It should be well designed so that individuals involved in the operating process may easily use and understand it. Okay, when to use histogram? When the data in numerical information. Next, to analyzing what the output from supplier process look like. Next, to analyzing whether a process can meet the customer requirement, determining whether requirement. Next, determining whether the output of two or more process are different. Okay, the benefit of histogram. The process behavior will be shown from the shape of the histogram. Next, starting point for the improvement process. Next, the shape and size of the depressor will help identify otherwise hidden source or variation. And next, to determine the capability of a process. This is a histogram, example of histogram diagram. This is the type of histogram. We have bell shape, and next, right ski, next, bimodal, and next, multimodal, next, left ski, and then uniform histogram, and lastly, random histogram. This is the histogram diagram. We have the table and the histogram diagram. Okay, step to make a histogram diagram. First, collect information or data from the information given. Second, determine the range of the data. Third, calculate the size of the class interval. And next, separate the data collection in a number of groups. Next, plot the x and y axis and the scale of both types of axis. And then start drawing the graph from the information by following the frequency. Then write down the title of the histogram. And lastly, from the histogram graph, make the conclusion to improve the process. Okay, thank you.
My name is Muhammad Danish Azrin, and I will present about check sheet. Check sheet is actually invented by Dr. Kaoru Ishikawa, who was a Japanese organization theorist and a professor in the engineering faculty. A check sheet is a pre-made structure form for gathering and analyzing information. This is a general data collecting and analysis tools that can be used for a variety of applications. So when to use check sheet? When the data can be observed and collected repeatedly by a person. When they collect data on frequency or patterns of events, problems, defect location, defect causes, or similar issues. And the last one is collect data from a production process. So there is several procedure of check sheet. The first one is decide what problem that will be observed. Next, decide when the data will be collected for a specific period. Design the check sheet form and set up data that can be recorded by making check marks that data do not have to be recopied for analysis. Label all spaces on the check sheet form and test the check sheet for a short trial period to be sure It collects the accurate, appropriate data and make sure it easy to use. The last one is each time the targeted event or problem occurs, record on the check sheet. So this is example of check sheet. You can see that the mark stick represented as data collected in specific period. That's all for me. Thank you.
Assalamualaikum. My name is Fatin Nabila. I will present about cause and effect diagram. As you can see in the picture, this was example for cause and effect diagram. Okay, what is cause and effect diagram? It also known as fishbone diagram or Ishikawa diagram. This is because the diagram was resemble a fish skeleton. Okay, when to use it? When we identify possible causes for a problem, or when a team's thinking tends to fall into ruts. Okay, this is categories in cause and effect diagram. First, manpower. People engaged in the design and delivery of a product. Second, method. A process for doing the job and particular requirement. Third, machine. Any tools, facilities, and equipment used for production. Fourth, environment. The condition when the process operates. Fifth, measurement, manual or automatic inspection and physical measurement. And lastly, materials, raw material that needed to produce a desired end product. Okay, this benefit or importance, the cause and effect diagram in QC tools. Okay, first, break problems down into bite-sized pieces to find root cause. Next, common understanding of factor causing the problem. Third, help keep teams focused. And lastly, follow brainstorming related. Next steps. First, agree on a problem statement. Means we must know what is our problem statement. Second, brainstorm the major categories of causes of the problem. To make things easier, use generic heading such as manpower, method, machine, material, measurement, and environment. Lastly, write the category of causes as branches from main arrow.
Assalamualaikum, and my name is Christine Nurain, and I will present about flowchart. A flowchart is a type of diagram that represents a workflow or process. A flowchart can also be defined as a diagrammatic representation of algorithm, a step-by-step approach to solving a task. When to use flowchart, first, to develop understanding of how a process is done. Second, to study a process for improvement. Third, to communicate to others of how a process is done. Fourth, when better communication is needed between people involved in the same process. Fifth, to document a process. And lastly, when planning a project. Flowchart basic procedure. First, define the process to be diagrammed. Second, discuss and decide on the boundaries of your process. Third, brainstorm the activities that take place. Fourth, arrange the activities in proper sequence. Fifth, when all activities are included and everyone agrees that the sequence is correct, draw to show the flow of the process. And lastly, review the flowchart with others involved in the process. Okay, this symbol for flowchart. First, start. Second, input, process, output, and end. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Farizul Fadli bin Zulkarnain. Okay, for control chart. Control chart is also called show chart, statistical process, control chart. The control chart is a graph used to study how a process changes over time. Data are plotted in time order A control chart always has a central line for the average and upper line for the upper control limit and a lower line for the lower control limit. These lines are determined from historical data. By comparing current data, these lines, you can draw conclusion about whether the process variation is constant or unpredictable, out of control effect by special causes of variation. This versatile data collection and analysis tool can be used by a variety of industry and is considered one of the 7 basic quality tools. Control chart for variable data are used in pairs. The data chart monitors the average of the centering of the distribution of data from the process. The bottom chart monitors the range or the weight of the distribution. If your data was short in target practice, the average is where the short are clustering and the range is how tightly they are clustered. Control chart for attribute data are used singly. When to use a control chart? When controlling ongoing processes by finding and correcting problems as they occur. When predicting the expected range of outcome from a process. When determining whether a process is stable. When analyze pattern of process variation from special causes or common causes. When determining whether your quality improvement project should aim to prevent specific problems or make fundamental changes to the process. Basic procedure. Choose the appropriate control chart of your data. Determine the appropriate time period of collecting and plotting data. Collect data. Construct your chart and analyze the data. Look for out of control signal on the control chart. When one is identified, mark it on the chart and investigate the cause. Document how you investigated, what you learned, the cause and how it was corrected.
Assalamualaikum. My name is Muhammad Kamil bin Zainal. So I will present about the Pareto chart. For the Pareto principle, Vilfredo Pareto from 1848 to 1923, Italian economist developed this principle. Then 20% of the population has 80% of the wealth. The B. Juren used the term vital few, trivial many. He noted that 20% of the quality problem cause 80% of the dollar loss. For the purpose Pareto chart is, the purpose of the Pareto diagram is to separate the significant aspect of a problem from the trivial ones. The use of Pareto chart is, firstly, Pareto charts help team focus on the small number of really important problems of their course. Then they are useful for establishing priorities by showing which are the most critical problem to be tackled or cost to be addressed. Next, the Pareto chart helps team to focus their effort where they can have the greatest potential impact. Finally, when communicating with others about your data. So here is the Pareto chart procedure. First, develop a list of problem, item or cost to be compared. Then collect the data as per defined time frequency. Then tally for each item how often it occurs. Determine the grand total of all items. Next, find the percent of each item and list the item being compared in decreasing order of measure of comparison. Example, the most frequent to the least frequent. The cumulative percent for an item is the sum of the items percent of the total and that of all the other items that come before it in the ordering by rank. For the Pareto chart procedure, list the item on the horizontal axis of a graph from highest to lowest. Label the left vertical axis with the numbers, then label the right vertical axis with the cumulative percent. Then draw a line graph of the cumulative percent. The first point on the line graph should line up with the top of the first bar. Finally, analyze the diagram by identifying the most critical items. So when to use Pareto chart? When analyzing data about the frequency of problem or cause in a process. Then when there are many problems or cause and you want to focus on the most significant. Next, when analyzing broad cause by looking at their specific components. And finally, when communicating with others about your data. For my second presentation, present is about scatter diagram. First, a scatter diagram is used to examine the relationship between both the axes x and y with one variable. In the graph, if the variables are correlated, then the point drops along a curve or line. A scatter diagram or scatter plot gives an idea of the nature of relationship. In a scatter correlation diagram, if all the points stretch in one line, then the correlation is perfect and is in unity. Then the scatter points are widely scattered throughout the line. Then the correlation is said to be low. And then if the scatter point rests near a line or on a line, then the correlation is said to be linear. When to use a scatter diagram is when you have pair numerical data. Second, it is the best method to show you a nonlinear pattern. Then the range of data flow, maximum and minimum value can be easily determined. And observation and reading is straightforward. And finally, plotting the diagram is relatively simple. Benefit of scatter diagram is it shows the relationship between two variables. It is the best method to show you a nonlinear pattern. Then the range of data flow, maximum and minimum value can be easily determined. Okay, next, the observation and reading is straightforward. And plotting the diagram is relatively simple. So here the scatter diagram correlation. It is divided to few type of correlation, which are first perfect positive correlation and perfect negative correlation. Next, high degree of positive and high degree of negative correlation. And low degree of positive and low degree of negative correlation. And finally, it is about no correlation. So for the scatter diagram procedure, first collect pairs of data where a relationship is suspect and draw a graph with the independent variable on the horizontal axis and dependent variable on the vertical axis. For each pair of data, put a dot or symbol where the x-axis value intersect the y-axis. Then look at the pattern of point to see if a relationship is obvious. If the data clearly form a line or a curve, you may stop because variables are correlated. You may wish to use regression or correlation analysis now. Otherwise, complete step 4 through 7. Divide point on the graph into 4 quadrants if there are x points on the graph. So count x divided by 2 points from top to bottom and draw a horizontal line. Then count x over 2 points from left to right and draw a vertical line. And also, if number of points is odd, draw the line through the middle point. So count the point is in each quadrant. Do not count point on a line. Next, add the diagonally opposite quadrant. Find the smallest sum and the total point of point in all quadrant. A, point in upper left plus point in lower right. B, point in upper right plus point in lower left. And Q is the smaller of A and B. Then N is equal A plus B. And finally, look up the limit for N on the trend test table. If Q is less than the limit, the two variables are related. But if Q is greater than or equal to the limit, the pattern could have occurred from random chance. So that's all for me.